Good morning, good afternoon, good evening, everybody, wherever you are. My name is Katya, and I'm very glad to welcome you to another NetXMS webinar. It's been a very, very long time. There are a couple of great topics to cover today. Most of them cover the new functionality in NetXMS 5, version 5, new major release. There are significantly reworked network maps, and Tanya is going to expand on that. And then the word will go to Victor, and he will talk about the new approach to monitoring of wireless networks and collector objects. Yes, there will be a recording after the webinar, so no worries. If you won't manage to get to the end of this call, we got you covered. And now I'm giving the word to Tanya, and she will start with the network maps. Tanya, the word to you.
Yeah, hi, my name is Tatiana. I'm one of NetXMS developers. So let me share my screen. So let's talk about network maps. There were multiple changes. One of the changes was that now we before the last release, you were be able to move objects to edit map, and then you were required to remember to push the save button. Now we a bit reworked this flow, so currently you can push edit button, then you can move the nodes. Node move will be automatically saved and refreshed, and after you finished the editing of the map, you just click, click edit button, and that's all. Now map is not editable, but you don't need to remember to push the save button. Another things that were improved, now we have options for the network map link, like line style. For example, let's use dot. Let's increase line width to 10 and move line label. So you can see it's possible to change line styling to exact line or for the whole map in the properties of the network map. One more thing worth to mention is that now our maps have the size. You can see this line that shows us the size of the map. Why is it important? So first of all, you can, with this size, you can say till which point network map background should go, as well as if you have a huge map with a lot of objects. Before that, you were required to zoom out, then you choose automatic layout, and then it's like normally spreaded. Now automatic layout takes into the consideration not the area that you currently see, but the whole area of the map. So you can set for the map with really a lot of objects, you can set really big sizes, and then it will be extended. This map with automatic layout will spread all the nodes according to the full size of the map, not just the area that you see. Another thing that was improved is zoom in and zoom out. So when you zoom in, the labels and the text also zooms in, and it's the same with zoom out, but in zoom out, the labels for the links are a bit extended so that they are still visible to the eyes, because before that labels were not changed while you were zooming in or zooming out. Another cool feature that was done this release is link styling script. So we're able to create our network maps automatically, like layer 2 network maps or IP topology network maps, but it was not possible to update those links accordingly. So now we have this link styling script. So when your L2 network map is created, you can make some additional changes with this script. For example, to add some data collection items on the links or add some information on the links. Currently, in this map, let me add one more note. Oh, let me add my own note. Let me, sorry. Okay. Let me link them. Now we have linked nodes. And when the automatic poll is done, I will do it with hands. You can see that now this link has a label. This label was populated automatically. It's like some dummy example. Much more things can be done with this functionality. But in this case, I just populate the link with the names of the node from one side and from another side. Another improvement is link color source. So currently, like before the last release, it was able to make color based on interface status, based on interface objects. Additional option was added based on the interface utilization. So for the interface utilization, you need to do multiple things. One is to set the interfaces that connects those objects. In my case, here I've created it manually. In case of level 2 topology, then there will be already objects selected. So in my case, I can select here some objects. Pointer. Pointer 16. So yeah, I've added objects. I've selected that color is based on interface utilization. And another thing that should be configured, you should have a data collection item with outbound traffic. And it should be configured that this DCI should be used, this DCI should be related to the object as well, and it should be interpreted as interface outbound traffic, and you should select the right option. Then on this interface, we can see inbound utilization and outbound utilization calculated automatically if the DCI was configured correctly. As well, it will be shown here on this link, the utilization. As you saw, I'm currently using my wireless interface, and there is no utilization on the Ethernet, but it will that's why it's gray. So the colors will be from gray till the red. So somewhere in between, there is a blue color for 50% of utilization. But yeah, so this is basically how it works. So I think those are the main features. For sure, we made some additional improvements for usability, how like some hidden stuff like the speed of work, but mainly this is all visible improvements. So now I can give the word to the Victor. He will tell us more about new types of objects that were created. So thank you.
Okay, so hello everybody. So as you likely know, we have wireless monitoring functionality for quite a long time in NetXMS. And it was done in a bit confusing way. So before that, we had a node, and if this node was actually a wireless access point or a wireless controller, we created a separate object called access points behind that node to represent either physically separated devices managed by wireless controller, or kind of virtual access points when we have everything inside one device. And this was not very convenient in a scenario when you have actual controller, you have geographically distributed access points managed by that controller, and you maybe want to put them in a separate containers, etc. It was not possible. They were all collected behind the node object. On the other hand, when you have a simple access point that you monitor through SNMP, it's no point to create virtual devices to represent basically the same functionality. So now I will share my screen and show how we done it in version 5. So here we have, we basically separated those two types of devices, wireless controllers. That is a device that does not provide wireless access by itself, but it controls multiple access points that do provide actual wireless access, and standalone wireless access points, like you have this MikroTik devices, for example, when you have small box that is completely standalone. So now, if you add a node, and this node is actually a wireless access point, like I have MikroTik here, for example, we now have two different capabilities. Is it wireless access point or is it wireless controller? And here we have, see, it's a wireless access point. So if we expand it, we just see normal network interfaces, no more access point objects behind. And this node got additional views dedicated to wireless functionality. Basically, it's a radio, so you can see the radio interfaces on this access point with SSID, etc. And you have a wireless stations where you can see all wireless stations registered on this access point. So pretty simple, no extra objects here, and you can work with it as with a normal node. And situation is more interesting when you have wireless controllers. So I have here a wireless controller. On the wireless controller, in the capabilities, you see we have a wireless controller capability and no access point capability. If we expand it, again, we just see network interfaces, so no access points. How we get actual access points managed by that controller? We introduced a new object class, which is called wireless domain. Let's create one. And initially it's empty, but it will contain access points. And you can add one or more wireless controllers to the wireless domain. Similar to how you add nodes to the cluster. This helps covering situation when you have, for example, two controllers managing all access points in a specific domain, or maybe you just want to combine all your access points managed by multiple controllers into a single structure. So you add your controller to the domain. So now we have controller under the domain, and then the domain will do a configuration poll periodically. I will do one manually. So as you can see, when we run configuration poll, it will read a list of access points managed by the controllers and will create a separate objects under wireless domain for each access point. So here my wireless controller reports only one access point, so otherwise you will get more. And if you select the access point, you see it's a separate device. You see vendor, model number, etc. And then you have your radio interfaces. And you have a wireless stations that are registered on this particular controller, sorry, on this particular access point. And it's a normal freestanding object, so it has data collection. So you can create data collection items on it. You can freely bind it to other containers, etc. So I can create a new container, for example, test, and I can bind my access point. And so I have my access point in a separate container. So you can build your own hierarchy of access points based on geography, based on model, whatever structure you want. And you can, they still will be kind of here on the wireless domain. And this list will be updated automatically. So if you connect more access points to your controller, they eventually will appear here on the next configuration poll for the wireless domain. You can run individual configuration poll on the access point to reread information about it. You can, of course, have this instance discovery poll, so you can create instance discovery DCIs and so on. So this simplifies management of the wireless devices in your network, and it makes it more logical and more flexible in the same time. And so that's about new wireless monitoring functionality. And a quick overview of another new object class that we added to NetXMS version 5, which is called collector. Sometimes you have your container structure, but you may want to have some aggregated data on that container level. Before version 5, the option basically was to create a dummy node without IP address and configure those aggregation DCIs on that dummy node, which was not that logical, or maybe not that intuitive when you look for the data. So we introduced basically a new container type, which we call collector. It has all the properties of the container, plus it has data collection capabilities. So you still can bind nodes under it. It will change status and so on. So it works pretty much like a container. Plus, you have your data collection here. So you can create metrics. Of course, you cannot read SNMP or agent. Normally, it will be something script or internal.
But you still can read agents, just use the different source nodes.
Yes, of course, all the usual logic applies. So if you redefine source node, then of course you will have data from that node here on the collector. So it's a combination basically of a container and the dummy node functionality in one object. And of course, because when you create script DCIs, you have access to all the sub-objects, so you can actually do a collection from sub-objects and present some summary data on collector level. So basically that's it. Very quick overview of this nice new functionality. So that concludes our today's webinar. Thank you for listening, for viewing it. Feel free to ask questions on our forum, Telegram channel, any other media. We'll be happy to answer.
Yes, and you can answer, you can ask questions just ahead if you want us to include something in those webinars. Yeah, thank you.
Thank you. Bye.